Hello. In this example, we'll talk about how to deal with a demand function in Excel. And before we do some calculations, let's briefly revisit the interpretation of the demand function. Suppose you know the demand function for tickets for home games of a local baseball team. And suppose that demand is quantity equals 1000 minus 100 times the price. First of all, let's look at the slope of the demand. This is the value in front of the price. So that slope is negative 100, and its interpretation is it's the change in the number of tickets sold per $1 change in price of the ticket. So it's measured in tickets per dollar. And the interpretation is as follows. Every $1 increase in the price of tickets results in a decrease in the quantity demanded by 100. Or alternatively, you can say in a decrease in the number of tickets sold by 100. So the slope of the demand curve is measured in units per dollar, in this particular example, in tickets per dollar. Now, before we perform any calculations, we need to find what's called the inverse demand. Notice that the standard demand function has quantity on the left, and quantity is the expression of the price. The inverse demand is basically taking that demand function and solving it for the price, isolating the price term and looking at, for a particular quantity, what price it corresponds to. So I'm going to start with the original demand of 1000 minus 100 times the price. And then the next thing that I'm going to do is I'm going to switch the quantity term and the price term places. So that will mean that, let's see how to put it best. 100, let me put it this way. 100 times the price is going to equal 1000 minus the quantity. And finally, to solve for the price, I need to take this equation and divide it by the coefficient in front of the price. So price is going to equal 1000 minus the quantity divided by 100. So that will mean, let's put it here. Price equals 1000 divided by 100 is going to be 10. And the coefficient in front of quantity is 1. So 1 divided by 100 is 0.01 times the quantity. So these two equations, quantity equals 1000 minus 100 the price, and price equals 10 minus 0.01 of the quantity. These two equations correspond to one and the same line, except for in the first case, quantity is expressed as the function of price, which is the standard way, and in the second case, price is expressed as a function of quantity, which is what we call the inverse demand. Now, I'm going to take that inverse demand and calculate prices that correspond to the quantities in my table. So price is always going to equal 10 minus 0.01 of whatever quantity that I'm looking at. So when that quantity is 0, price is going to be 10. That means at price of 10, I'm going to sell exactly 0 tickets. And every time that quantity is going to increase by 100, you should expect the price to go down by 1, because you know what the slope of the demand curve is. So that gives me the prices. Now, with respect to total revenue, I just need to multiply price by quantity for every column in the demand curve. So it's just going to be the product of the two. So this first number should be 0 because we're not getting any revenue if we're not selling any tickets. And then if we sell 100 tickets at the price of 9, that will give us a revenue of 900. And 200 tickets at the price of 8, 1600, and so on, all the way to the very end. What about the marginal revenue? The marginal revenue is the increment in the total revenue. It's the change in the total revenue that corresponds to a slight change in price. In our case, the price will be dropped by 1 in every case, and the revenue, well, it's going to increase or decrease by some amount. How are we going to calculate it? What is the marginal revenue between 0 tickets and 100 tickets, or alternatively between $10 and $9. It's the total revenue at 9 minus the total revenue at 10. So that's going to equal total revenue corresponding to the new price minus total revenue corresponding to the old price. So the first dollar reduction in price increases our total revenue from 0 to 900. So the additional total revenue is 900. The second dollar reduction in price increases the revenue from 900 to 1600, which corresponds to a $700 increase in revenue. The next increase from 1600 to 2100 is just a $500 increase in revenue. And then if we expand the formula for the whole range, looks like the marginal revenue is decreasing, and at one point it starts being negative. That means lowering the price even more starts to reduce our revenue rather than increase it. And finally, let's calculate elasticity using the point elasticity formula. We know how to do that already. So for the point elasticity, we need to take the slope, which is negative 100, multiplied by price and divided by corresponding quantity. So the slope is going to stay the same, but the price and the quantity will be different in every column of the cell. So negative 9, expand it all the way. And I'm deliberately skipping the first number because in that first cell, if you calculate it using that formula, it will show you an error because you're dividing by 0 the quantity that corresponds to the first column is 0, so elasticity cannot be defined. Alright, so we filled out the whole table. So the next thing that I'm going to do is I'm going to highlight it, except for the elasticity, and I'm going to press Insert, Chart,